Consider the following. Comets are like time capsules. They are frozen messages from the period when our solar system was just forming from a cloud of gas and dust 4.5 billion years ago. We call them dirty snowballs, and there is logic to that. They are made up of ice, rocks, and organic materials, which are the fundamental building blocks from which our Earth emerged. Perhaps even we ourselves. We have sent probes to them, studied their chemical composition, and were confident that we fully understood their nature. It seemed like a solved problem, basic physics, if you will. However, there is an important rule in science. As soon as you conclude that you understand everything, the universe prepares an unexpected twist for you. It presents you with a challenge that forces you to reconsider all the textbooks. And that is exactly what happened. We created the most advanced instrument in history, the magnificent James Webb Space Telescope, our cornerstone in the study of the cosmos. We directed it at another icy wanderer, expecting to confirm our theories. Instead, we received data that absolutely does not fit within the known frameworks of physics. Data that indicates we have overlooked something very important. What we will discuss today is not just a scientific anomaly. It is a potential revolution in our perception of the cosmos. We are talking about an object designated as 3I over LAS. What it has shown us raises a question that until now has only been echoed in science fiction. What if we are dealing not with a natural phenomenon, but with technology? It all began, as it often does, with a routine observation. An automatic sky survey system from LAS, located in Hawaii, detected a dim, fast-moving object. Calculations and its trajectory left no doubt. Its orbit was hyperbolic. This meant only one thing. The visitor did not come from our solar system. It arrived from the interstellar void. It was assigned the designation I, which stands for interstellar. This was only the third confirmed visitor in the history of observations. The third, it was named 3I over LAS. Astronomers around the world pointed their telescopes at it. It turned out to be strange, too dim for its size. Its coma, a cloud of gas and dust, behaved unpredictably, flaring up and then almost disappearing. But the main detail was that its path passed very close to the sun, and then, almost perfectly, toward the observation point of our new cosmic sentinel, the James Webb Space Telescope. This was a unique opportunity. Never before had we had the chance to study an interstellar object with such astonishing detail as Webb is capable of. Its sensitive infrared detectors, cooled to nearly absolute zero, could see what is hidden from everyone else. To examine the chemical composition of primordial material from another star system. To understand whether the building blocks of other worlds are similar to ours. The observation plan was approved months in advance. A group of scientists held their breath, waiting for 3.3 to reach the desired point. None of them expected any sensational discoveries. No one. They were waiting for confirmations. Obtaining new data to refine existing models is a painstaking and, at first glance, tedious process related to fundamental science. However, the universe had its own plans. Just a few weeks before the scheduled observations of Comet EBA, something unusual occurred. As it approached the sun, under the influence of its heat and gravitational field, the comet broke apart into 3 pieces. This moment surprised many, as typically intact objects are of greater interest, but not for the EBA team. Now they faced an exciting task, to study not only the comet itself, but also its internal structure, which had finally become accessible after the destruction. To see what had remained hidden beneath the icy shell for millions of years. And so, at the appointed hour, the golden honeycomb mirror of the James EBA turned toward the point in space where the comet had recently been. Now, clouds of its debris were slowly drifting there. Thousands of seconds of invaluable observational time were spent gathering information coming from this cosmic tombstone. Data began to arrive on Earth, and the silence I mentioned became increasingly palpable. To understand the scale of the shock, let us return for a moment to our textbooks. What is the breakup of a comet? It is a chaotic and disordered process. Imagine you exploded an ice block filled with dirt and stones. What do you get? Clouds of irregularly shaped fragments scattering under the influence of inertia. Large pieces, small particles, dust, gas, pure chaos. All our models and previous observations of comet breakups depicted exactly this picture: random and uncontrolled destruction. The first image obtained with the near-infrared camera NIRCam appeared on the screens at the Space Telescope Institute in Baltimore deep into the night. The people who saw it first thought it was a glitch, an artifact, a software error. The screen did not show chaos. It displayed order. Instead of a shapeless cloud of dust, Elda Webb saw almost perfect concentric shells. Dozens of the thinnest glowing spheres nested within one another resembled matryoshka dolls. They radiated outward from the center of the breakup with mathematically precise accuracy, and between them were perfectly dark gaps. But this was just the beginning. When the mid-infrared instrument MIRI, capable of detecting the thermal radiation of objects, came into play, the picture became even more astonishing. Inside these spheres, in seemingly empty gaps, MIRI discovered a structure. The thinnest threads connected the shells, forming perfect hexagons, honeycombs, identical to the shapes of the segments of the main mirror of the telescope itself. This seemed absurd. It was impossible. Nature does not create straight lines and perfect circles on such scales, especially after an explosion. This contradicted the fundamental laws of gas dynamics and celestial mechanics. The debris clouds behaved not like a result of disintegration, but like a result of unfolding, as if someone had pressed a button and a complex structure began to carefully reveal itself in space, layer by layer. The geometry turned out to be just the beginning of the puzzle. The next stage was spectroscopy. The spectrometer was not an ordinary camera. It was a powerful device capable of breaking down the light from any object into a spectrum and determining its exact chemical composition by analyzing the dark absorption lines. Scientists hoped to see familiar elements: water, carbon monoxide, methane, silicates. They found them. However, among the familiar lines were also those that should not have been there. The absorption lines corresponded to heavy refractory metals: tungsten, osmium, rhenium, in quantities many times greater than any conceivable concentrations in the interstellar medium. Moreover, isotopic analysis showed that the ratio of tungsten isotopes did not match any known natural source. This was not the result of a supernova explosion or the merger of neutron stars. It turned out to be artificial, as if someone had deliberately enriched the material with a specific stable isotope. And then came the third blow, the most devastating, from the field of thermodynamics. The instrument not only identifies structures, it measures their temperature. The data it transmitted made physicists around the world clutch their heads in disbelief. The comet debris turned out to be colder than the surrounding cosmic vacuum. Allow me to repeat that. Objects that had been under the bright rays of the sun just a few weeks ago were several degrees colder than the relic radiation. Their temperature was below 270 degrees Celsius. They were not just cooling down, they were actively cooling. They were entropy refrigerators. This was a direct, visible, and recorded violation of the second law of thermodynamics. Heat cannot spontaneously flow from a colder body to a hotter one. A system cannot spontaneously decrease its entropy without an external source of energy. Yet these debris were doing just that. They were dissipating heat into the void, becoming colder than the void itself. This was the end. Geometry, chemistry, physics. The three pillars of our understanding of the universe were overturned by a single observation, a disintegrating piece of stellar ice. The data was verified multiple times. Errors and unaccounted factors were sought, and nothing was found. The James Webb Space Telescope was functioning flawlessly. It simply showed what was actually there. Scientists were left alone with a fact that their minds refused to accept. 3. Eye drop, at last. This was not a comet. So what was it, really? Here we leave the solid ground of facts and step onto the shaky territory of hypotheses, and the further we go, the more troubling they become. The first hypothesis. The most conservative. It is held by skeptics and those who desperately try to maintain the familiar worldview. It is formulated as follows. We have encountered a completely new, unknown natural phenomenon. Perhaps in the interstellar medium, in protoplanetary disks around other stars, there may exist conditions under which complex crystalline structures form from frozen gases and metallic dust. It is possible that under the influence of powerful magnetic fields, these structures acquire order. Normal chemistry is merely a characteristic of that part of the galaxy from which this object originated. As for the violation of thermodynamic laws, we may be observing some kind of quantum effect at a macroscopic level that we cannot yet explain. The phase transition of matter into a completely unknown state is a convenient hypothesis. It drives research. It suggests that we are simply not informed enough. It maintains the status quo but does not explain everything. It does not provide an answer to the question of the mathematical precision of the structure, nor does it explain the isotopic ratios at the molecular level. It requires belief in a chain of incredible coincidences. Is this merely a coincidence? The second hypothesis is bolder. It ventures into territory that serious science usually prefers to avoid. What if this is a form of life, neither biological nor carbon-based? Silicon-based, crystalline. A form of life for which the icy vacuum is a natural habitat, a structure capable of self-organization and self-reproduction. For it, decay under the influence of a star is not an end, but a means of reproduction, a revelation akin to blooming. The release of spores, these geometric constructs that may drift to other star systems over millions of years. Anomalous cooling is merely a byproduct of its metabolism, a way to maintain its internal structure in a superconducting and superstable state. This is a beautiful, almost poetic idea. It expands the concept of life to limits we could not even imagine. It transforms the cold, dead universe into a potential garden of crystalline beings. But this hypothesis also has its weakness. Why would this form of life need artificial and complex tungsten? Why such excessive complexity for mere survival? This brings us to the third hypothesis, the one that no one discusses at official conferences, the one whispered about in the corridors, the one that keeps gray-haired professors awake at night, gazing at the starry sky with new feelings, a mix of awe and primal terror. The hypothesis that three unidentified objects are artifacts. What is this? Something created intentionally. In this paradigm, everything suddenly falls into place. Perfect geometry is not a natural anomaly, but an artificial solution, a structural element, an unfolding antenna or map. A three-dimensional map, unfurled in space, where the position of each sphere and each thread carries meaning. The anomalous chemical composition is not a coincidence but a building material. Super strong and refractory alloys capable of withstanding millions of years of interstellar travel. Artificial isotopes are a marker, a signature, a quality sign indicating that this was made by us, while the violation of the second law of thermodynamics represents a functioning engine, computer, or life support system. something that continues to operate even after the outer shell has been destroyed, something that still executes its program. What was that program? What was the purpose of this object? A messenger? Was it a probe that, after completing its mission of gathering information about our system, self-destructed, leaving only data for its creators? Perhaps it was a capsule, a kind of Noah's Ark, carrying knowledge or even the seeds of another civilization. And its destruction is not an end, but a new beginning, activation, the scattering of seeds in a new, receptive system. Or was it something much more alarming? Perhaps it was a weapon, a warning system that sent a signal upon crossing a certain gravitational zone. There is someone here. They are evolving. They have begun to look at the stars. We do not know what is happening. We have stunning images capturing perfect spheres of hexagons slowly melting in the void. These photographs actually represent one of the most significant discoveries in human history. And at the same time, they are the most classified. Because, as you understand, such information cannot simply become public knowledge. It has the potential to destroy religions, economies, and our very perception of our place in the universe. It carries an existential risk that we are simply not prepared for. As we gaze at the heavens, we have asked ourselves the same question. Are we alone in the universe? We have sent radio signals, only to hear cosmic noise in response. The Fermi paradox. Where is everyone? It weighed on us with its unresolved nature. We searched for intelligent brothers, hoping to hear their voices. But what if they never intended to speak? What if their language is not radio waves, but geometry? Not mathematics at the level of the mind, but mathematics embodied in matter? What if the universe is not silent at all, but communicates with us in geometric whispers, and we, with our primitive technology, until recently, simply could not hear it? The object 3-Idearob came and went. More precisely, it remained. Now it is part of our solar system. Billions of its microscopic fragments, each possibly carrying information. They are already settling on planets, including our own. They are here, among us. The James Webb Space Telescope has revealed to us what we were not meant to see, or conversely, what we were destined to see. It has opened Pandora's box, and now we face a choice: to pretend that we have noticed nothing and continue living in the cozy world of our old theories, or to acknowledge that the game has changed, that we are no longer lonely children in our sandbox, that in the vast, dark ocean of the cosmos, there are others, and one of them just threw a bottle with a message right at our feet, and we have no idea what it says, an invitation or a warning. Perhaps the greatest mysteries are not what is hidden out there in the depths of space, but what will now happen here, on this small blue planet, after we have learned. What do you think about it? What has James Webb really sent us? Another riddle of nature or the first meaningful signal? If this troubles you as much as it troubles me, stay with us. We will continue our exploration of the boundaries of knowledge together.